All right, chemistry students, you should be looking at the worksheet that says Understanding the Gas Law Equations right now. And I'm just going to take you through the 6 different laws that you're going to see. And this paper is going to be something that becomes very helpful to you because it's going to have all the laws, and it's going to show you what the equation is, it's going to show you the relationship, and it's also going to tell you when to use the equation. So if you start out with Boyle's law compares pressure and volume. And so we usually write it P1 V1 equals P2 V2. And when you're using Boyle's law, you can only have pressure and volume changing. Everything else must remain constant. And we gave you an example right here to show you that an inverse relationship has, when it has an increase of pressure, it has a decrease of volume. They do something different. And then with this one, when the pressure goes down, the inverse would be that the volume would go up. And you can use Boyle's law when you are given pressure, and pressure has a lot of different units. You might see ATM for atmosphere. You might see millimeters of mercury. You might see kPa, that stands for kilopascals. You might even see torr. So you can write those down. And then you also have to be given volume. And most commonly you'd see milliliters or liters for your volume. All right, let's go on to Charles' law. Charles' law involves volume and temperature, and then everything else stays constant. And you'll notice that this equation looks different. With Boyle, the pressure and the volume are multiplied together, and with Charles, they actually have a fraction bar. So you have V1 over T1 equals V2 over T2. And when you see an equation like this, you know they're directly related. So when you think about the relationship, an increase in temperature will give you an increase in volume. And you'll notice that's different from Boyle's law, which was inverse. So a decrease in temperature would give you a decrease in volume. And so you would use Charles' law when you're given temperature. And you know that temperature is usually given in Fahrenheit or Celsius, but for Charles' law, you have to have your units in Kelvin. So I'm going to write K for Kelvin, but it could be Celsius or Fahrenheit, and you just have to change it first. And there's actually an equation for that at the bottom of this worksheet. And then same for volume as Boyle's law. It's usually in milliliters or liters. So there's your first two laws. We'll go down here to all right, so I just got our worksheet moved down, and now we can see Gay-Lussac's law. And Gay-Lussac's law involves pressure and temperature. And you see that the arrangement of your variables looks similar to Charles' law. And that's because pressure and temperature are related directly, just like volume and temperature were. So when you write this one, an increase in one variable, like T, would cause an increase in your other variable, P, and a decrease in T would cause a decrease in P. And you would use Gay-Lussac's law when you're given pressure. And so you can write the same units that you wrote before. You could have atmospheres, you could have millimeters of mercury, kilopascals, or torr. And then temperature, this law also has to be in Kelvin. All right, and then actually when you take all three laws, Boyle, Charles, and Gay-Lussac's, you can put all three variables, pressure, volume, and temperature, into what's called the combined gas law. And so you'll have P1 V1 over T1 equals, that is a 1 right there, equals P2 V2 over T2. We've already written the relationship, so we're going to skip that part. And then here you would need to be given pressure, temperature, and volume, and they all need to change. All three of these variables change in the same problem. So I'm not going to rewrite the units again because we've done that above. All right, so we've got our fifth law now. We've got the ideal gas law, and that equation combines all of your variables as before, except this time you can't have two pressures. You can only have one pressure. You can have one volume. N now stands for number of moles. R is a constant, and then T is a temperature. And so this over here it says, for how do I know when to use this equation? When you are given all but one of each. So you've got pressure, volume, and in this case you usually want your volume to be in liters, so go ahead and write that with an L. You've got number of moles, which is N, and you've got temperature, in Kelvin. All right, now another thing I want you to try to fit into the ideal gas law is what R can be. R is a constant. Rarely would you ever solve for R. You're usually given R and you just plug it in. And there's three different R's that you can use. One R is 0.821, and you use that R when pressure is in atmospheres. Another R value is 8.31, and you use that R when pressure is in kilopascals. And your third R option is 62.4, and you use that one if pressure is in millimeters of mercury. So it may seem a little confusing by being three different values, but you just check to see what units your pressure's in, and once you figure that out, you pick the R that goes with it, and you just plug it into the equation over here. And then it just becomes a matter of solving for algebra, solving for one of your variables, just like you would in algebra. The last law is called Dalton's law of partial pressures, and it simply says that the total pressure of a mixture of gases is equal to the sum of all the partial pressures. So you simply just add all your pressures up to get the total. And what you'd write in here is when you're given a mixture of gases and the partial pressure of each individual gas. So now that you've got all this filled in, you're going to want to keep this sheet handy because it's got all the equations on it. If you're stuck on a problem, it's going to give you a good place to start because you can kind of look through the table and compare what you're given in your problem to what these little hints say on the right-hand side of your table to try to figure out what law you're going to use. So keep that handy, and you can start solving some gas law problems now.